Imagine trying to fix a typo in a book, but every time you erase a letter, you leave a scar on the page. That's the genomic scar bottleneck, one of the biggest limitations of first-generation CRISPR gene editing. Every cut in the DNA risks unwanted mutations, making precise repairs tricky and sometimes dangerous. But what if we could edit our genetic code with the finesse of a pencil, or even better, a word processor? Enter base editing and prime editing, the next-gen tools that are rewriting the rules of gene therapy. Think of base editing as swapping out a single letter in a word, like changing an A to a G, without ever breaking the DNA strand. It's like using a pencil eraser to gently correct a typo, leaving the rest of the sentence untouched. This precision is already making waves in diseases like sickle cell anemia, where a single letter change in the hemoglobin gene causes red blood cells to deform. With base editing, scientists can correct that single mutation, potentially curing the disease at its source. Now, prime editing takes it a step further. Imagine you're not just fixing a typo, but using a search and replace function in a document. Prime editing can add, remove, or swap entire DNA sequences, opening the door to treating more complex genetic disorders. For example, cystic fibrosis is caused by various mutations in the CFTR gene. Prime editing could, in theory, search for the faulty sequence and replace it with the correct one, offering hope to thousands of patients. But editing genes is only half the battle. Delivering these molecular tools to the right cells at the right time is a massive challenge. Scientists use delivery vectors, like viral particles or lipid nanoparticles, to ferry the editors into cells. It's a bit like sending a highly skilled repair crew to a single house in a sprawling city. The trick is making sure they reach the right address without causing chaos elsewhere. And then there's the ethical side. As these technologies advance, so do the questions. Who decides which genes to edit? How do we prevent misuse? Regulatory frameworks and ethical guardrails are evolving alongside the science, aiming to balance innovation with responsibility. Looking ahead, next-gen gene editing could transform how we treat muscular dystrophies, rare metabolic disorders, and even some cancers. The dream is a future where genetic conditions are not a life sentence, but a problem we can fix at the source. The tools are sharper, the edits cleaner, and the possibilities almost limitless. If you want to see how gene editing could change medicine forever, keep watching this space.